Hello students and welcome to IP Study lecture videos. In this video, we are going to cover the fourth chapter of grade 8 mathematics, and the name of the chapter is cubes and cube roots. Students, before going into the chapter, let us understand what are the different topics we are going to cover under this chapter. So we'll see what is the meaning of cube of a number. We'll see the different properties of cube numbers, and we'll see how to find the cube root of a number, of a perfect cube. Yes. Now student, what is cubes and cube roots? We have already understood what is the meaning of squares and square roots in our previous chapter, where we multiply a number by itself like this and we get a number which is called the square of the number that we are using. For example, let's suppose if we multiply 5 with itself, the number obtained, that is 25, is the square of the number 5. So similar to this concept where we write 2 as an exponent on the number like this to represent the square of a number, we use 5. Let's suppose if we take a number 5 and we write its exponent as 3. So this expression is called cube of 5. So cube of a number means multiplying a number by itself 2 times. So if we multiply 5 by 5 one time, then 5 2 times, then this expression is called cube of 5, which will give us 125. So cube is quite a similar concept to square, where instead of finding out the product by multiplying a number by itself, we multiply the number by itself 2 times. Yes. Now here are some definitions that say what is the meaning of cube of a number. So I have already told you that multiplying a number by itself 2 times, writing a number first, multiplying by the same number, then multiplying again by the same number. The whole expression is called cubing of the number, and the result is called cube of the number. Yes. Now what is perfect cube, students? So student, we have already understood what are perfect squares. So square of 1 is 1, square of 2 is 4, square of 3 is 9. So this number 1, 4, 9 are called perfect square, that we have already understood. But perfect cubes are similar, but here instead, let's suppose if you have 1, then cube of 1 is 1, cube of 2 is 8, cube of 3 is 27. So this number 1, 8, 27 are called perfect cube. So it is quite similar pattern. You can just follow the same trend over here. Yes. Now to check whether a number is a perfect cube or not, so this is also a similar method. We will find out the prime factors, we'll group them into 3, or we'll find the, or we group into 3 like making them as a triplet. Yes. So if we make triplets of the prime factors, and if all the prime factors are made in that form, or possible to be made in that form, then the number is a perfect cube. If some prime factors left without making them a triplet, then the number will not be a perfect cube, and that number will call non-perfect cube. Yes. Now there is a concept that smallest number that should be multiplied or divided to make a perfect cube. So it is also similar to the square numbers that we have seen. So we will find the prime factorization of the given number, and we'll see what is the number needed to make the prime factors a triplet. So let's suppose if we have 1188 and we find out the prime factorization like this, we can see that here all the prime factors cannot be make into triplets. So like here we have 2 which need 1 more 2, and here we have 11 which needs 2 more 11s to make a triplet. So here we multiply the given number with these numbers that we need, and the number that should be multiplied here is 242. So the new number that we will obtain by multiplying this will be a perfect cube, which can be find it out by like this, and it can be represented like this. Yes, 66 raised to the power of 3. And how we come over here, so we'll see in the later part of the video. Now student, here are some question, example 1, example 2 and example 3, which you can go through. These are based on the same concept that we have already understood. Now next topic is properties of cubes of a numbers. So students, similar to the properties of square numbers, some properties are also followed by cubes of numbers. So first is cube of numbers 0, 1, 4, 5, 6 and 9, or any numbers ending with these digits end with the same digit at the unit place. Let's suppose if we find out the cube of a number ending with the digit 1, let's suppose 11. So cube of 11 is 1331. Now the unit digit is again 1. So the unit digit of 11 is also 1. The unit digit of its cube is also 1. So it says that if number is ending with these digits, then their cubes will also end in the same unit digit. Yes. Similarly, cube of 2 and the number having 2 at its unit place is 8. If we have a number such that the unit digit is 2, then its cube have a unit digit 8. So here are some more properties that you can go through. Yes. Now let me take this property. The cube of any multiple of 3 is divisible by 3. So if there is 3 or multiple of 3 like 6, 9, if we cube them like 9, cube of 9, then it will be divided by 27 and the remainder will be 0 in that case. Okay. So the next topic is special pattern in a cube. Student, there is a pattern that can be observed in cube of numbers. So it says if we want to find out cube of some number, let's suppose 5 cube, then consider n as 5, and if you use this formula or you can say terms, you can find out the numbers that should be added to get this cube. Like here we have first member as n minus 1, then n, and we have to add 1 also like this, then n minus 1 plus 3, and until you get a number where you will find out that the sum is 0. So if you take 5 over here, so we'll write 5 minus 1 plus 1. So it will be 5 times 4 plus 1, 21. So here we can see 21, then you'll see 23, 25, 27, 29. It means it will be increased by 2, and the number of terms that we are taking is equals to the number n that we have taken. So here 1, 2, 3, 4, 5 numbers are taken, and the sum will be cube of the number that we have considered, that is 5. Yes. Now moving to the next topic, that is cube root of a number. What does it mean? So let's suppose if you multiply a number 7 3 times, it will give us 343. Now we can write it as 3 raised to the power of 3, or we can read it as cube of 7. Now student, the cube of 7 is 343, but we can also say the cube root of 343 is 7. So it is quite the reverse thing that we are going to understand, that what was the number that was multiplied by itself 2 more times such that we get the number that is given over here. Yes. So cube root, like square root, is denoted like this. Let's suppose if you have 49, we represent it like this, or we can use a format where 2 is written to represent the square root, and it can be written like this. But for cube root, it is specially mentioned that we have to write 3 in the place over here, and we have to write the number for which we have to find the cube root. So this sign is called radical sign, and here the number which should be which are used to find out the cube root is called radicand, and the index that we have using is, or the number that we have using is called the index of the radical. Yes, here are some examples of how to find cube root of numbers. Now here we have a pattern which says, from the above pattern we conclude, there is a pattern, and it says from the above pattern we conclude that any cube number can be written as a sum of 1, 7, 19, 37. So there are certain set of numbers which when added will result into cube of the numbers like this. If we have taken this set of numbers, 5 set of numbers, it will result into cube of 5. Yes. Now there are certain methods to find the cube root of numbers. One is repeated subtraction and other is prime factorization. So in repeated subtraction, we take this set of numbers, that is 1, 7, 19, and this set of numbers can be finded out using 1 plus n times n minus 1 times 3. So if we use this format, where let's suppose if we put n is equals to 1, so the number will be 1 only. Similarly, if we put n is equals to 2, so it will be 1 plus 2 times 1 plus 3, which will be 7. So the second member will be 7. So if we try to find out different members, we'll get this series 1, 7, 19, 37, 61. So try to find more numbers in this, you can say group or series. Yes. Now, how to find the cube root of numbers using repeated subtraction? So we will take this group of numbers, that is 1, 7, 19, 37 and 61, and we'll start subtracting one by one until we reaches 0, and the number of steps taken to reach 0 is the cube root of the number. So let's suppose if we have 343, and if we subtract the numbers starting from 1, then 7 and then 19 from the resulting numbers, so we'll reach 0 after 7 steps. So the cube root of 343 is 7. So this method is quite easy for small numbers, but for large numbers this will be a tedious and more time taking task. So for that we have a method called prime factorization method, which is quite similar to the square root method of what we have understood in our previous chapter. So here we find out the prime factors of the given numbers and we make triplets of them, and we take one number from each group and then multiply them to get the cube root of the number, like this 2 times 3 times 3, which is 18. Now there was a special case or special method or short trick method to find the square root of a number looking at the unit digit and the rest of the digit that we have seen. Yes, similar to that we have cube root using tens and unit digit. So for that what we can do is we have a method, look at the digit at the unit place of the perfect cube and determine the digit at the unit place. So depending upon the unit digit of the given number, we can identify what would be the unit digit of the cube root of that number. Let's suppose if we have a number which has a unit digit 8, it means the cube root of this number will have unit digit 2. So first of all identify the unit digit of the cube root. Yes. Now like this we have a list of numbers and how the unit digit will be for that number. Strike out the last 3. Let's suppose if we have 175,616, so strike out these 3. We're left with the remaining part, that is 175 for this case. Last 3 digit of the number, if nothing is left, the digit in the step 1 is the cube root. If there is no number, then the unit digit that you have considered, that is for 6 we have 6, so answer will be 6. But here we have 1775. So let's see what we have to do. Take the number left in step 2, find the largest single digit whose cube is less than or equals to this leftover. So we have to find out the largest but nearest to 175 and less than 175, which is a perfect cube. So we know that the cube of 6 is 616, cube of 5 is 125. So this is the smallest cube, perfect cube numbers, that is nearest to 175. It means the tens place will have 5. Yes, because this is the number that we have understood. So here the answer will be 56, because the unit digit was 6 and the tens digit was 5. So the cube root of this number is 56. So this is quite easy method to find out the cube root of a given number if it is a perfect cube. Now student, there are some questions that you can go through in this exercise, and this is all from this chapter, students. I hope you understood the chapter very well. So we'll meet in the next chapter. Until then, keep practicing, keep learning.